Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I am going to start review of fundamentals of states of matters part 2, that is the liquid and solid state. Review of liquid and solid states. Already I have discussed in details. Now I am going to only review of the review of fundamentals of liquid and solid states. First point, many terms are there, one by one I will discuss. First term is, or first point is characteristic properties of liquids. Characteristic properties of liquids. First point, no definite shape. Second point, definite volume. Third, higher density than gases. Fourth, much less compressible than gases. Fifth, diffuses like gases, but diffusion is slower. The distance of separation between the molecules of liquid lie in the range of 10 to the power minus 5 to 10 to the power minus 7 centimeter. This question is asked. The distance of separation between the molecules of a liquid lie in the range of 10 to the power minus 5 to 10 to the power minus 7 centimeter. Second term, vapor pressure. Vapor pressure. What is the vapor pressure? It is the pressure exerted by the vapors present in equilibrium with the liquid at a particular temperature. It is the pressure, vapor pressure is the pressure exerted by vapors present in equilibrium with liquid at a particular temperature. Means when liquids will convert to vapor, then that time there will be equilibrium. Equilibrium will exist, means a liquid will convert to vapor and vapor will come back to the liquid. There equilibrium will exist. That is at a particular temperature. Then at that time, what was the pressure? That is called vapor pressure. Means when vapor and liquid both are in equilibrium, means liquid is converting to vapor, vapor is suppose coming to back, then there will be equilibrium state. Then that time pressure due to vapors are called vapor pressure. Then vapor pressure exerted by the vapors present in equilibrium with liquid at a particular temperature. Now third point, cooling caused by evaporation. Cooling caused by evaporation. What is this? This is because the molecules with higher kinetic energy leaves the liquid. As a result, the average kinetic energy of the liquids falls, and so the temperature falls. This is the main reason of cooling caused by evaporation. Again, I am repeating. Cooling caused by evaporation. This is why does it happen? That I am telling you. This is because the molecules with higher kinetic energy leave the liquid. As a result, the average kinetic energy of the liquid falls, and so the temperature falls. Now next point, factors affecting evaporation. First factor is nature of the liquid, and second factor is temperature. Then first factor, nature of liquid. Weaker are the intermolecular forces, higher is the vapor pressure. Just to remember, weaker are the intermolecular forces, higher is the vapor pressure. This is the first factor, that is the nature of liquid. In any liquid, if intermolecular forces are weak, then vapor pressure will be more. Second point, temperature. Higher the temperature, higher is the vapor pressure. Means in a simple way, molecules will be free. Molecules will feel free. Correct? Because if intermolecular forces are weak, that time also they will be free. And when temperature is high, that time also they will get momentum, then they will move fast. Hence, you can say these two are the factors affecting the evaporation. First is the nature of liquid, second, temperature. Now next term, that is the boiling point of a liquid. Boiling point. What is the boiling point? It is the temperature at which the vapor pressure of the liquid becomes equal to the external pressure, that is atmospheric pressure. Again I am telling you, boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the external pressure, or you can tell atmospheric pressure. If external pressure is normal atmospheric pressure, if external pressure is normal atmospheric pressure, that is the 760 mm, the boiling point is called normal boiling point. Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. If external pressure is normal atmospheric pressure, that is the 760 millimeter, the boiling point is called normal boiling point. Now next point, difference between boiling and evaporation. Then first I will tell evaporation. Evaporation takes place at all temperature, whereas boiling takes place at a particular temperature. Second, evaporation takes place only from the surface of the liquid, whereas boiling involves the formation of bubbles below the surface. This is the difference. Again, I am telling you differences between boiling and evaporation. First, evaporation takes place at all temperature, whereas boiling takes place at a particular temperature. Second, evaporation takes place only from the surface of the liquid, whereas boiling involves the formation of bubbles below the surface. Next term, heat of vaporization. Heat of vaporization. What is heat of vaporization? It is the amount of heat required to change 1 mole of the liquid into its vapor at the boiling point. Next term is surface tension. What is surface tension? It is the force acting at right angles to the surface of liquid along 1 meter or 1 centimeter length of the surface. Again, I am repeating surface tension. Question is asked. It is the force acting at right angles to the surface of liquid along 1 meter or 1 centimeter length of the surface. The units of surface tension are newtons per meter. That is, also you can tell newtons per meter, N, capital N per meter. Or you can tell dynes per centimeter. In dynes per centimeter, dynes per centimeter, and other newtons per meter. Newton you can write N, capital N, newtons per meter or dynes per centimeter. These are the units of surface tension. Next point is surface energy. What is surface energy? It is the energy. Energy means work done. Remember, work is also energy. Heat is also energy. Remember. Then what is the surface energy? The work in ergs. Erg is the unit. Erg and joule. Correct? These are the units of energy. Then what is the surface energy? The work in ergs required to increase or extend the surface by 1 square centimeter is called surface energy. Again I am telling you, the work in ergs required to increase or extend the surface area by 1 square centimeter is called surface energy. Its unit are ergs per centimeter square. Okay, ergs per centimeter square or joule per meter square, means Cm power minus 2 or ergs Cm power minus 2 erg per centimeter square or joule per meter square. Correct? Now next point, that is the effect of surface tension. This question is very, very important. Effect of surface tension. It tends to decrease the surface area. What actually surface tension will do, that I am telling you, that is called effect of surface tension. It tends to decrease the surface area of the liquid to minimum. It tends to decrease the surface area of the liquid to minimum. That's why falling drops are spherical, because a sphere has minimum surface area for the given volume. The rise of a liquid in a capillary is also due to surface tension. These are the effects of surface tension. One more time I am telling you, it tends to decrease the surface area of the liquid to minimum. That's why falling drops are spherical, because a sphere has a minimum surface area for the given volume. The rise of a liquid in a capillary is also due to surface tension. Next point, effect of temperature on surface tension. Question is asked. Surface tension decreases with increase in temperature and becomes zero at the critical temperature. Again you listen. Surface tension decreases with increase in temperature and becomes zero at the critical temperature. Surface tension decreases with increase in temperature and becomes zero at the critical temperature. Now, next term, this another point I am telling you, that is this viscosity. What is viscosity? Another term is viscosity. What is the viscosity? It is very, very important term. Always question is asked. Then in a simple way you can tell, viscosity is the internal resistance of a liquid to flow. Whether some liquid flows fast, some liquid will flow slow. Why? Then this is due to the internal resistance. If internal resistance is more, then liquid will flow slow. If internal resistance is less, then it will move fast. It will flow fast. Then viscosity is the internal resistance of a liquid to flow. Next term, force of friction. Force of friction between two layers of a liquid. Now I am going to discuss expression. Correct? I am going to discuss expression. Okay. Then for that we should understand force of friction expression. I will tell you. Expression of force of friction. Force of friction between two layers of a liquid, each having area capital A centimeter square. Correct? Always friction will be between two layers of a liquid, and each liquid having area how much? Capital A centimeter square, separated by a distance x centimeter. Two layers are there. Then one layer, each layer is area is capital A centimeter square, and distance between the two layers is x centimeter, having velocity difference v centimeter per second. Actually both layers have, suppose both are moving, then obviously when they are moving, then their velocity, so they have some velocity, then both layers may have different velocities. Then now suppose that difference in both velocity is v centimeter per second. Difference in both velocities of both layers. Correct? And both layers are x centimeter. Their distance are separated by a distance x centimeter, and capital A is the surface area. Correct? Three things I told you: surface area, distance between the surface area, and distance between the difference between the velocities. That is the velocity difference, v centimeter per second. Then force of friction F is proportional to this force of friction between the two layers of a liquid, that is proportional to, directly proportional to surface area and velocities difference, and it is directly, and it is this you can say, first I told you directly proportional to surface area and velocity difference. This is the directly, and inversely proportional to distance, that is the x. Correct? It means F is directly proportional to capital A into V and down x. means directly proportional to surface area and velocity. That's why you can write A into B, velocity difference, and inversely proportional to x. Then you can write F is proportional sign capital A into B divided by x. If you want to this proportionality sign convert into equality, then you have to multiply by some constant. That constant is here called eta. Eta, that is coefficient of viscosity. Eta is called coefficient of viscosity. Then F is equal to a small f. Force of friction is equal to eta into capital A into V divided by x. X will be down. All three will be up. Okay, eta into A into V divided by x, where eta is called coefficient of viscosity. This question is asked. Actually, 3 questions generally will ask whether that how A is F and A is how related, then it is directly proportional. How velocity difference is related, then it is also directly proportional. How distance between the two are related, then it is inversely proportional. And then what is the eta? Eta, then for that again you can easily you can define what is the eta. Means coefficient of viscosity. Then coefficient, to define the coefficient of viscosity, only you have to imagine if x is equal to 1 centimeter, means 2 layers are there. Suppose both are have distance 1 centimeter, means x is equal to 1 centimeter. Area is equal to 1 centimeter square. Each have 1 centimeter square. A means 1 centimeter square. And suppose V, velocity difference is that also 1 centimeter per second. All are 1, all 3. Then if you put the value of all 3 in the expression, then what you will get? F will be 1 into 1 divided by 1 into eta. Then only eta will remain, all will be again further 1. Means F is equal to eta. F is equal to eta, because all 3 terms are 1 only. A is equal to 1 centimeter square, V is equal to 1 centimeter per second, and distance is 1 centimeter. X is equal to 1 centimeter. After putting all value, you will get F is equal to eta. Means eta, that is the coefficient of viscosity, is the force of friction at this condition. When you will apply this condition, that time force of friction between 2 layers is called coefficient of viscosity. Correct? Coefficient of viscosity. Now further I am telling you that is the unit of coefficient of viscosity. One more thing, coefficient of viscosity, about that I want to tell you. Coefficient of viscosity is the force of friction in a dynes. Okay, this coefficient of viscosity is the force of friction. I have proved you. Now you have this, that F is equal to N, you have seen. Then coefficient of viscosity is the force of friction in a dynes, because you are using the term centimeter, hence will be in dynes. Then this coefficient of viscosity is the force of friction in dynes required to maintain velocity difference of 1 centimeter per second between 2 parallel layers of 1 centimeter apart, and each having an area of 1 centimeter square, both layers. Then this is the definition of coefficient of viscosity. Again, one more time, I am telling you, coefficient of viscosity is the force of friction in dynes required to maintain a velocity difference of 1 centimeter per second between two parallel layers 1 centimeter apart and each having an area of 1 centimeter square. Next term is unit of coefficient of viscosity. Then by expression you can by knowing, if expression you are knowing for force of friction, then unit also you can know, coefficient of viscosity. Then here eta is equal to, that is the distance. By expression you can get the value of eta, because a small f is equal to eta into a into v into x. Then what is the a? Then a will be this things f is equal to eta into a into v divided by x. Then eta is equal to what? Cross multiplication you do, then you will get f into x divided by av. F into x divided by av, that is the eta, means a coefficient of viscosity. After that, just simply unit you write, that is the F, this is the force. Then force unit is dyne. Here force unit is dynes. X is measured in centimeter, divided by a, area is centimeter square, into v, down a into v is there, the a is centimeter square, and v is velocity, that is the centimeter per second. Then after cancelling, what will remain? That is the coefficient of viscosity, means upside dyne into centimeter, down centimeter square into centimeter per second. Then 1 centimeter will be cancelled. Then what will remain? Upside only dynes will remain. Down centimeter is there, centimeter square will remain, and per second. Then centimeter square, if it will go up, it will be minus. Then centimeter minus 2. And second was s minus 1, down centimeter per second. Then upside it will go only s, you can write, means second only. Then our unit became unit of coefficient of viscosity, dynes, centimeter minus 2, means per centimeter square, into what? S means here it was the velocity per second, correct? Now centimeter per second, then s is the second, then its unit became dynes, centimeter minus 2 second. Okay, dynes per centimeter square into second. Three terms are there, dynes, centimeter minus 2 or per centimeter square into second. And this is called poise, 1 poise. This is actually poise is the name of scientist. Then dynes, centimeter minus 2, power minus 2, dynes, centimeter power minus 2 into second. These actually are, this is called actually 1 poise. Okay, question is asked. 1 poise is equal to, 1 poise is the equal to dynes centimeter power minus 2 into second. Okay. Now one more point I want to discuss. Let's say the last point, effect of temperature on viscosity. Effect of temperature on viscosity. Then you keep in mind, it is very easy, question is asked. The viscosity of a liquid decreases with increase of temperature by about 2% per degree rise of temperature. Two question is asked. Simply it is asked first question whether this viscosity will decrease or increase or decrease. That question is asked. If temperature will increase, then how will it affect viscosity? First question. And second question is asked how much it will increase or decrease. Then listen carefully. Viscosity of liquid decreases with increase of temperature. First things. How much? Then about 2% per degree rise of temperature. If you increase the temperature by 1 degree, then this viscosity will decrease, means it will move fast. Liquid will move fast if you will warm. Okay, for each degree 2% it will increase. Okay, the viscosity of liquid decreases with increase in temperature by about 2% per degree rise of temperature. Now I am stopping only here. Next class I will discuss solid state. Okay, liquid state finished. Thank you.